Hello and welcome. I'm your host Ruby Gill, and I feel honored to welcome you all on the behalf of lovely professional university. So attendees, what do you think the essence of this webinar? Well, I'm glad to share with much excitement that today our expert will deliver his expertise and make us learn about mechanics of light. So I'm sure you all will also be excited to be the part of today's webinar. So kindly allow me to introduce our experts. Dr. Amit Thakur, Professor, Head, Aerospace Engineering, School of Mechanical Engineering, lovely professional university. A dynamic professional with an experience of 19 years in academics and research. His interest lies in renewable energy technologies, biofuels, thermal engineering, aerodynamics, robotics, and Internet of Things. To his credit, he has more than 140 published patents with 22 innovative Australian granted patents, and also he has to his account more than 41 papers published in renowned journals and book chapters. He has undertaken and supervised 11 MTech theses and 4 PhD theses as well. He is a proud member of editorial boards of 5 international peer-reviewed journals, and also he was the research sub-coordinator of ADRDE DRDO project of design and development of the declaration system for space capsule recovery recovery experiments. So, sir, it's a privilege to have you on board with us today. Thank you so much for joining us.
Thank you so much, Ravina. Thank you.
Furthermore, I would like to welcome our admission expert, Mr. Neeraj Sharma, Senior Officer, lovely professional university. So with an experience of 15 years, his expertise lies in business development, marketing, and product promotions. And attendees today, he'll give you an insight of eligibility, fee, and scholarship, which I'm sure will make you save a lot of money. And in addition to that, he'll also be sharing the infrastructure part of the university. So thank you so much, sir, for joining us today.
Thank you, ma'am. Thank you.
So with this, we'll begin today's webinar. I welcome you all again to the webinar and looking forward for a great interactive session. So over to you, Amit, sir, for the content of the day.
Thank you so much, ma'am. Thank you. All right. Warm good evening, everyone, one and all present over here. So I would just like to share it up to you all. I think so. I hope so. My screen is visible to everyone, and
Yes,
we'll be talking about more onto this part. All right. So this is we are talking about mechanics of flight today. All those aerospace aspirants who really want to come up in this particular field, we can talk about this mechanics of flight today. I'll not go in much of details. I'll just give you an overview of this today. So it will be like one thing for you all. So coming to your mechanics of flight, we talk about the history of basic early ships, that what we consider, right? So when we talk about basic early ships way back in 18th century, there is some theory being provided that through explosion you could propel a machine, right? And that theory was completely based on third law of motion. And coming after that, Henry Gifford, which could rightly see it onto my screen over here. This was Henry Gifford's airship. It was way back in 18th century somewhere, and it was being considered to be the most powerful one and the first aircraft engine. This was being powered with the first aircraft engine and having 3 horsepower steam engines. It was very heavy in comparison, and it was very heavy to fly also. So this airship normally successfully flew on 24th of September somewhere in 1852, and it covered near about 27 miles, like 27 kilometers approximately. And the engine was not that so powerful that it could overcome those prevailing winds, because once the aircraft is in the air, you find air coming from all together on all directions. All right, so Griffith has to return back his flight back, uh, and the top speed that what we normally talked about at that particular time, it was 6 miles per hour. However, he managed to circle this airship in slow circles, and proving that if at all the weather is very calm, this airship would have been to a beneficial onto it. All right, and there were further unsuccessful efforts that was being done throughout into these particular era, like Hiram Maxim. He also tried out with certain triplane. 1986, we had unmanned airplane. All right, we had unmanned airplane where it was being powered by a steam engine, and that was called aerodrome. And then further it came down with that Otto Daimler in late 1800, where he invented the first gasoline engine. That is what we are talking about today, is that a petrol engine. And after that, everything came up into account. So in 1903, something which we called a flyer. Wright brothers came up with a flyer that was a near about 12 horsepower gas-powered engine. All right, and in late 1930s, this gas-powered engine was being used as a reciprocating engine. That was internal combustion engine, and it was having a propeller, just a propeller, the sole means to propel that particular aircraft. All right, so coming to this particular very important concept that everybody should know about it, right? What I want to talk about, what basically is an airplane? If I'm talking about an airplane and an aircraft, there are two different conceptions that what we consider over here. So if you look onto this particular, when I say aircraft, there's a difference between an aircraft and airplane. So if I look onto this diagram over here, you see this figure which clearly identifies aircraft is a more general term. And when we talk about heavier than air, that is what is basically being supported by its own buoyancy, all right, and by its own structures. When I'm saying an airplane, that is something again heavier than aircraft, but it uses some aerodynamic surface to generate wings. That means an aircraft and an airplane. When we talk about an aircraft and an airplane, we can come down to one important conclusion, that every airplane is an aircraft, but not every aircraft is an airplane. That is very important. When I'm talking about every airplane, that is considered to be an aircraft, but not every aircraft is an airplane. Because see, I told you about an airplane, it is something which we are using aerodynamic surfaces like wings, basically to what? To generate lift, right? So that is the basic difference between an aircraft and an airplane. That is what we talk about normally. So this is how it looks like. So in airplane, you talk about something which is called space shuttle, you have gliders, you have helicopters. So that is what is considered to be an airplane. So every airplane is an aircraft, but not every aircraft is an airplane. And then talking about why there are so many of types in modern aircrafts, why we are talking about so many types. We're talking about so many types because we are talking about for a specific purpose, right? So specific purpose, it can be anything. We can talk about different altitudes, different speeds, different weight carrying capacities, different performance parameters. All right. So when we talk about for jet aircrafts, you see jet aircrafts, they are relatively very lightweighted. And you normally see they are very highly maneuverable, and they are very fast. And they carry a small amount of weight, including that fuel, and that could be refueling during the long flights. And similarly, we have passenger aircraft. So every aircraft, they have their own ways and means, like they are being divided into that particular part. So coming to the parts, basic parts of that airplane, that what we talk about, 5 structural components that what we consider: fuselage, wings, empennage, propulsion system, undercarriage. That is what we talk about normally, and everybody knows that, right? So the components is something which we discuss it over here. See, fuselage we have the wings part of it, then the empennage. Empennage is something which is called the tail area, right? The tail end, which is basically assisting us to stability, providing the stability of it. Then the power plant, that what we consider, then the landing gear. These are the basic parts of it. Coming to your fuselage part, fuselage is what is your main body structure, and all other components are being attached to it. It contains a cockpit, you have passengers, cargoes, and that produces a small amount of lift, and but that also produces a small amount of drag also. Okay, And wings, when we consider the most important lifting part, surface of that wing, and these wings basically they carry the fuel, and they are designed in such a fashion that these are sometimes dihedral and anhedral, right? So when I'm talking about a dihedral, I'll just give you a small concept of the dihedral part over here. When the wings are being lifted up from the ground, we have find the dihedral angle over here. You must have seen Antonov, right? Antonov aircrafts, which are like military aircrafts, they have anhedral wings, where the wings are completely towards downward side. So what basically these dihedral do, they provide some kind of rolling action to this airplane. So having a dihedral angle will help the plane to roll better. Okay. So when we consider these all, these are two kinds of wings classification, or rather say the attachment, or say the orientation of those wings. That would be, one is called the dihedral part, another one is called the anhedral part. And then when we consider the empennage part of it, this whole empennage section, that is considered to be the tail assembly. And the basic function of this empennage is to provide your stability and control. And you could be having two main parts of it. One is considered to be the vertical stabilizer, another one is the horizontal stabilizer. So when I'm saying the vertical stabilizer, everybody knows that. Horizontal stabilizer, what are the basic units onto it? And then coming back to the undercarriage part of it, these are also known as landing gears. Sometimes this undercarriage is also being considered to be landing gears, all right? And these are made up of struts, wheels, you have brakes, and it could be fixed and retractable both ways, all right? So this is what the undercarriage. And then coming down to that main powerhouse of that aircraft is considered to be the propulsion system. When I'm talking about propulsion system, what exactly this propulsion system provides to us? That is going to provide you the amount of thrust that is required for the airplane, right? And there could be different kind of engines. We talk about piston engines, we talk about propellers, we talk about turboprops, we talk about turbojets, we have a turbofan, then further scramjet and ramjets, which are considered to be on the rocket propulsion side of it. All right, so these are the propulsion systems. And then we have certain controls. What are the controls? These controls can be embedded inside the cockpit. These are certain instruments and controls that basically supplies what? Supplies you the altitude part of it. Where are you right now? At what position you are? What position is the aircraft is? What is the direction in which we are flying onto it? And how exactly we are going to steer, right? Engine power, braking system, all these are being provided through this controls part of it. And these are the three motions that what we normally consider onto it. So if you could look onto it, this is what is called yawing. This is what is called pitching, and this is what is called rolling. I'll just show it a bit more in details of it. If at all you'll be able to understand that. Okay, I'll come to that. Before that, let us talk about this particular part, an aerofoil. If I look onto this, every aircraft is have these wings. They are basically made up of aerofoils. Like if I say aerofoils, that is nothing but a two-dimensional part, right? It's being considered as a 2D section. If I'm saying a 2D section of a wing, so if you look onto this particular wing over here, you could see this is what is the aerofoil. So you see the shape like this. This shape is basically considered to be of aerofoil shape. This is a cut view of a wing, right? And if I'm talking about a 2D section, now the question is why this particular shape? Now, why this shape was being adopted? Why this is the shape that what we normally talk about of an aerofoils, or normally the wings that what we have? All right, this is what is how the wings is being made. The reason is very simple. The reason is self-explanable into this particular slide that what we see it over here. You could see it over here, like if I initiate, there were tests being carried along. There were experiments being done in way back in scientists, they did it. So on a flat plate, this is a flat plate that what we see it over here. So when we see flows flowing, this is the fluid, right? Fluid could be anything, guys. It could be air, it could be water, it could be anything. So here what we are talking about is air, because aircrafts are flying in the flying up, so there will be air surrounding towards it, right? So this air, when it flows onto this particular flat plate, or say this particular plate or a wedge, it is getting separated. You see, these are the circular wakes that what we find it over here. So in case of a flat plate, the disturbances of this flow was very huge, due to which what happened, there is a lot of drag that was being generated. The resistance to the flow is immense. Then the shape of circular, bit of circular part it came along, not exactly circular, but yes, bit of circular. So coming from a flat plate to a circular, you could see the wake formation zone or the disturbances behind the wake formation zone is considered to be less, right? This is a sphere. And then a sphere with a pharynx was being attached. So here you could observe, once the aerodynamic shape of this particular body is being increased further, you see the wake formation zone was less. That means the resistance to the flow was less. The flow remained attached to this particular flow. And then further, this sphere was being considered in-house spheric. So further, you see the wake formation zone becomes more or less. So finally, it came down to this particular shape, and it boiled down to this particular shape, where it was being presumed that the flow which is flowing over this particular aerofoil will flow smoothly through it. Now, the concept of this came, all this concept came from one important principle, that is what is called the Bernoulli's principle, right? Everybody knows about this Bernoulli's principle. So that we consider that all these energies, that is pressure energy, kinetic energy, and the datum energy, all are remaining constant. So this is what Bernoulli's principle speaks about, right? So that everybody knows, pressure energy, kinetic energy, and potential energy per unit volume. That's what we talk about. And this is how the application of this Bernoulli's theorem can be applied onto this aerofoils, that what we see. Now you could see it over here. Onto that aerofoil, the flow structure over here on the top surface is considered to be flowing through it, right? So if it is an aerofoil, the flow is considered to be streamlined. And this is that concept of how the pressure is being generated. So if you find this is that wing, and I told you this wing is made up of aerofoils, right? So when the air is moving on to this upper surface of this particular wing, that is in fact flowing much faster, right? And so the pressure that is considered to be less pressure, which is downwards acting. But the pressure of the wing, pressure of the air which is below the wing surface is considered to be more. So that's the reason why you see there is a difference in the pressure. So due to that pressure difference, we normally get a lifting force. And that is what is the basics of the lift force, that what we talk about. So it is the difference of pressure between the upper surface as well as the lower surface of the wing which generates that kind of lift, that kind of what do you call it, force that is being generated, which lifts the aircraft upward from that ground. All right. So coming to all those forces that everybody should understand, this is what is your lift is, and this is the weight of that airplane, and that is what is considered to be the gravity which is being pulled down by gravity. This is the drag, and this is the thrust. So thrust is somewhere where the engines are, and the engines are giving you the thrust, which is basically taking you to propel that aircraft further ahead. And then the drag is something which is opposing this thrust. So whenever we talk about a flight, we need to understand that this thrust has to be much more in order to overcome this drag. So that's the reason why we keep on changing engines. We talk about a propeller, we talk about a turbojet, we talk about a turboprop. So your engine has to be powerful enough to overcome that particular drag. All right, so you need to build up, and this is the concept that what I told you about. This is how an airplane flies. All right, so this is what is basically that what you could see the cross section over here. So the basic difference, the pressure difference, due to the difference of that particular pressure, the airplane tries to lift up from that particular ground. All right, now the concept is onto this particular aerofoil, how long can we talk about flow structures? So how long the flow can be considered to be streamlined? So then came down a very important concept, which is considered to be that angle of attack. When I'm saying angle of attack, it is something which is the angle between the chord line as well as with the free stream, that what we talk about. So you see at 10 degrees angle of attack, you are not getting any kind of disturbances, right? As the angle of attack starts increasing, that means as we are going to increase the angle of attack from 10 degrees to 16 degrees and then further to 17 degrees, you find the wake formation zone. These white ones, that what you see it over here, these are considered to be the wake formation zone. And if you look onto this particular graph, this is called the coefficient of lift, or say the amount of lift that is being generated. So when I'm talking about lift, the force which basically takes up you into that air, we talk in terms of coefficient of lift. So how much is the value of the coefficient of lift? So you could see at an angle of attack of 10 degrees, you are having a maximum lift of 1.2 or 1.3 somewhere. But as you see, when you're going beyond 15 degrees to 20 degrees, your coefficient of lift starts decreasing down. Why it is decreasing? Because due to this wake formation zone, due to the flow separation that what occurs over here, that is what is considered to be that stalling of aerofoil. So if I'm talking about a stalling part, stalling is something where the flow is trying to get separated. All right. So once the flow starts getting separated, you will no longer be able to get that maximum amount of lift that is possible. So in order to overcome that, again, scientists worked onto it. So they came up with certain flaps and slats. All right. So I'll not discuss onto that. So coming to that particular part, that is considered to be addition of flaps and slats will delay the separation, and further you can raise up your CL value. You can take down your CL value to even 1.3, 1.4, 1.5, even move to 1.6 also. All right, and the angle of attack, that flow separation, will be somewhere beyond 17 to 18 degrees. So in that particular way, we can enhance the stalling. We can delay the stalling. All right, so delaying the stalling will give you better performance abilities. Then we could talk about the stability and the control part of it. This is what we discussed about, right? So when you see an aircraft, we have three axes. One is considered to be the pitch axis. So whenever from now onwards, whenever you see an aircraft, the axis which is passing through the wings is considered to be the pitch axis. The axis which is passing through that fuselage, if you see the axis which runs parallel to this, that is considered to be that roll axis, and which is perpendicular, something which is perpendicular to it, vertical, that is considered to be that yaw axis. So if you observe the figures carefully, you'll be able to understand that. Now if you see this is what is considered to be your when nose up and down movement. So if I'm talking about, so now you see the controls that are basically being utilized over there. This is at that empennage. This is what is your horizontal tail, right? So putting this horizontal tail, so all these controls are there at that particular, just managing that. This is what is considered to be pitching. So when I'm saying a pitching motion, that is something which is nose up and down. Similarly, when we talk about, you look into this, you talk about rolling. Rolling is something about the swing axis. Now you see, once you're rolling it up, these are the ailerons, right? So up, down, if you do it, this is considered to be that rolling about one particular axis. So rolling is something which is sliding to this particular left and then to the right. And then we have yawing. So yawing is something which is called directional. That is being done by the rudders. That what you see it over there at the back, right? So it is something which is to the left and the right. So yawing something to the left, yawing something. That means just in order to get the directions. Like if the pilot wants to turn from this particular point to go down to a different heading, he has to switch on his rudders. He could operate his rudders, right, in order to take up to a different direction. So that is what is considered to be yawing. So these are the different motions that what we talk about. And coming to this horizontal stabilizer, that is what you see it over here. These are the horizontal stabilizers. So these are the elevators, and how exactly the forces are being acted upon to it. That is what is the point of concentrations. All right, and these are the ailerons that what we see. See left aileron, right aileron, and how exactly the forces are being balanced. Right force and the left force, how exactly we are going to roll it, right? So that is being done by the ailerons. Then one important thing is considered to be spoilers. Like everybody has learned about these spoilers. Now see, these spoilers are somewhere the word comes along. The spoilers are the ones which are going to spoil your lift, because the lift is somewhere where we are getting just to operate that aircraft in order to move up, right? So if I am coming down or landing, if I'm landing onto an airport or somewhere, we don't require that lift. I require more drag, because I want that resistance. I want the aircraft to slow down. Okay, so in order to slow down, we use these spoilers. And readily, when you are there in an aircraft, you could have observed those spoilers opening up and closing of spoilers, right? So these spoilers are just to destroy that particular part of lift. Okay, so the lift is being destroyed by the spoilers, and these are being opened during that landing part only. So apart from spoilers, all these fighters, you have seen normally these fighters, they utilize those parachutes also, right? Because these parachutes, they have huge amount of resistance to the flow, right? So these are the spoilers. And then these are the vertical stabilizers, that what I told you, which is containing a rudder part of it. So horizontal, vertical stabilizers. These are the few maneuvers that what we consider along. All right. So normally we talk about all these aircrafts which are lightweighted, or these are performing certain sort of maneuvers. So I just wanted to show you some pictures of maneuvers. I'll not go in detail of that. So these are certain spin. They are spin. They can enter into a spin part of it. So maneuverings can be of different kinds. This is a loop that could be taken for an aircraft, and these are being done with a light-weighted aircraft, not with a heavy-weighted. Passengers aircrafts are not supposed to perform maneuvers, right? So coming back to this is what is called the action of rolling onto it. Then the most important part is what is considered to be engine. And as according to the definition part of engine, that what we consider, the engine is something which we consider to be a motor or a machine, which is basically designed to convert energy into useful mechanical motion, right? So when we consider these kinds of engines, there can be different parts of it. So what basically an engine does, a machine which basically tries to produce thrust to push an object forward. Okay, and so these are the types of engines that what we consider normally. The amount of thrust basically depends upon how much is that mass flow through that engine and the exit velocity of that particular gas. All right. So different types of engines, and what are those different types of engines, why they are different types of engines, that is all being based on Newton's first law of motion. So I'll not go into Newton's first law. I'll just show you the different types propulsion systems. What are those? They are basically two. See, when I'm talking about piston and jet engines, you have seen these piston engines readily, which we have a lighter aircraft, all those Hansas and two-seaters and three-seaters aircraft, they normally have these piston engines. And when we talk about a heavy passenger aircraft like Boeing 747, 737, you talk about Airbus, they all have these jet engines, right? So jet engines are considered to be more powerful as compared to other engines. So if you could see, this is what is how the piston engines looks like. So it's something which is considered to be a piston engine, which is having a propeller over here. So you could observe a propeller right at the top over here, which basically rotates. These are basically done onto piston engines part of it. And this is what is called a reciprocating, that what we discussed about that, right? So having cylinders and pistons all together where it works. So it could be a 4-cylinder, 3-cylinder all together. So this is the piston part of it. And then the jet engines, that what we consider. So what exactly jet engines does? That is considered to be reaction engines. Like I'll show you the types basically. So these are the various types of jet engines. You can talk about a turbojet, you can talk about a turbofan, then you can talk about a turboprop. We have a ramjet engine and a turbosaft engine, and the scramjets are also there. But coming to the turbojets engine, these are something which are turbojets. So a unique feature of these turbojets is that they are having compressors and turbines in tandem. All right, so the compressors basically they suck in. This is the inlet part of it from where the air is being blown into the compressors, right? And the compresses the air, and further it is being channelized to the combustion chamber where it is being burned, and then further it is being expanded down to the turbine. So this turbine is basically driving this compressor. So you'll be having a burner also, you'll be having a nozzle, and then the further the exhaust is being exhausting out through the nozzle with a heavy velocity. So sometimes these turbojets, they come with an afterburner also. Why? Because there are sometimes fuel which are being left along. All right, so we need to burn that part also. So that is how the turbojet engine looks like. And then you talk about a turbofan. This is something which is called a turbofan engine, where we have a certain sort of bypass air also, which is moving in. The same comprises of compressors and all. All right, and then we have a turboprop. There's a propeller which is moving into that upstream part of it. Then you have their gear reductions over here, which we basically reduces that speed. All right, and this is which is considered to be a propeller being attached, and then further the fuel is being burned over here, the combination of turbojet. Okay, and then the ramjets. These ramjets are considered to be an important one. One important thing is that these ramjets, they do not contain any moving part. All right. So these ramjets are basically being utilized for rockets and high-speed propulsions. Like when we're talking about rocket engines, they all have ramjets, right? So we need to propel that particular engine further into that space, because see, they don't have a moving part. So they require certain amount of thrust to be propelled first. So initially they are being initiated with certain sort of rockets. So you could see the Mach number which we're talking about, the Mach number is considered to be greater than 1, right? And further in the combustion chambers, that is being compressed and it's being burned, and then further it is being exhausted. So all these ramjet engines are considered to be without engine. They don't have compressors and turbines. They don't have any moving parts. But initially they have to be boosted up using rockets. All right. So these are the ramjets. And then we have a turbo shaft, which is having a gearbox attached to it also, where we have a gear reductions, where you can reduce that speed part of it. And the obsolete, these are very obsolete nowadays. So what the basically that is being utilized is now normally nowadays is turbojet engines only. All right, so that is what we talked about, all these engines part of it, and that is what I just gave you the brief introduction of what I have. So thank you guys, thank you everyone. That is what we try to come up to that end part of it. Thank you.
Thank you so much, sir. This was such an impactful presentation, and you have bounded us with your visionary thoughts. And audience, thank you so much for your patience and participation. I'm sure that you must have upgraded your skills by the inputs and learning shared by our expert. So, sir, we have, before we move on to our admission
Please
expert.
unmute yourself, please. Your voice is not coming.
All right, so am I audible now?
Still, it is not.
So there might be, I think, network issue from your end. Can you hear me, sir, now? Hello, sir.
Any questions, any queries are there? I would love to
Yes,
take
sir.
up
Yes,
that.
we have few queries from our
I think so
attendees.
your voice is not audible, ma'am.
Neeraj, sir, can you hear me?
Yes,
No,
Ruby
still
ma'am.
not.
Well, I can hear you.
Amit, sir, there might be some technical glitch from your end that you are unable to hear me.
Can you hear me? I can't hear your voice.
Yes, sir, we can hear you loud and clear.
Well, you are audible. We can hear you.
Yes, sir. Okay, so we'll do one thing. We'll move on to our admission expert first. So Neeraj, sir, over to you for the admission part till the issue will be resolved till the time I believe so. So over to you, sir, for the admission part of the university.
Okay, thank you, ma'am. Good afternoon, all of you. Before we proceed further with the presentation, right, what I would like to tell you, I would like to brief you a little bit about LPU first, then we'll switch on to presentation part, right? So if we put LPU, LPU is India's largest private university in terms of area and number of students on a single campus. We have only one campus, which is situated in Fagwara, very close to Jalandhar in Punjab. It's such a big campus that the whole area is in more than 600 acres of land. And if you talk about strength, we have more than 30,000 students who are studying here, and they're from 50 different countries. And if I talk about the facilities, we have each and every facility available within the campus. Like we do have a huge mall here. There is a big hospital. We do have more than 100 food courts, and of course separate hostel facilities for boys and girls, which are 100% safe. Then we have an indoor stadium with all the game facilities available. There are many banks, ATMs, post office. So all such facilities which a student needs in day-to-day life, they are available within the campus itself. And if I talk about the number of programs, you'll be surprised to know that we are running more than 100 programs from our campus, which are starting from 10th onwards diploma till post PhD. So it's a very big campus. So I'll just switch on to the presentation part and we'll brief you about the campus life and other areas, right? So before that, I would like to tell you that even if I talk about the campus area, right? So the campus area, if you say that yes, we have more than 600, but in total, if we talk about it, is more than 800 acres of land, which includes the research area and other part of the campus. Now coming to the presentation part, right? So if I talk about, you can just see that the presentation in front of you, the very first slide speaks the laurels about the LPU students. There were 13 LPU students who participated in the Tokyo Olympic Games in 2020, and we are proud to share that 10% of the Indian Olympic participants were LPU students. And if I talk about The second slide, the LPU team members, they have lifted the runners-up trophy at Khelo India University Games, and none other than our Honorable Home Minister, Mr. Amit Shah, along with the Sports Minister, Mr. Anurag Thakur. He was the one who awarded the runners-up trophy to our LPU team members. Then coming to the ranking part, right? So again, I feel proud to share that if I talk about Times Higher Education Impact Rankings 2022, so LPU ranks at 74th position globally. And there is another ranking which we call Times Higher Education World University Rankings, that is 2022. So LPU is ranked at 36th position among the top universities of India. And that includes both government as well as private universities. And if I talk about subject-wise ranking, we are second in business and economics, 8th in clinical and health, 9th in computer science, and of course 10th in engineering part. Then another big ranking which is called Atal Rankings of Institutions on Innovation Achievements, we stand at 3rd position in India. Now coming to the campus life and exposures offered, right? So on the very first slide, you can see our Honorable Prime Minister Shri Narendra Modi ji, he was here with us in our campus to inaugurate the Indian Science Congress. Then, of course, none other than His Excellency Dalai Lama, he was here with us in our campus to share his views. Then there was an occasion in one of the convocations, two ex-presidents, one ex-president of India, another ex-president of Afghanistan, they were sharing the dais at one of our convocations in LPU. Then none other than our ex-finance minister, Mr. Arun Jaitley ji, he was the one who inaugurated the startup school at LPU. Then Gohar Gopal Das, the spiritual guru, he was there with us to share his life experiences with all the students and faculty members. Then none other than the Hollywood icons like Shah Rukh Khan, Deepika, and you name the ones, you will find them here with us, with our students while sharing their experiences. Then Mr. Dhoni, yes, he was there with us in one of the events. Then talking about the infrastructure, if I show you the picture, this is a block where it is 12 blocks in together with the library and the ECE department in our campus. Then a very big auditorium which has a capacity of 2,500 people. And this is the mall which I was talking about. This mall is available within the campus with all the facilities. And the inner view of the mall, you can see different shops and other facilities available within the mall. Then centrally library available 24/7. Students can go and study anytime in the library, and it is fully air conditioned library. Of course, the recreational activities available within the campus. You can see the bowling area, then the gymnasium, and of course the hospital which I was talking about. We do have a 25-bedded hospital with a dental chair, and these are the inner view of the hospital. And the indoor stadium, it is such a big indoor stadium that we have an Olympic size swimming pool available there in the campus. In the indoor stadium, we do have other game facilities like basketball, volleyball, badminton, squash courts are there, and of course we do have a gun shooting range as well in the indoor stadium. This is the aerial view and the panoramic view at night time of our campus. Okay, now shifting to the other part. See, basically, if a student want to know the detail of the program, like if he or she is interested for a particular program, you need to visit our site, which is called lpu.in. That is the website of LPU. Once you reach on the very first page, you will find a tab by the name Admissions. So once you click this tab, you need to search the programs in which you are interested for. Like the ones who will be looking for undergraduate programs, they look for after 12th programs. After graduation PG programs, we do have after PG programs, and of course doctoral program, as well as 10th based programs after 10th, which are diplomas. So now today we were discussing about the aerospace engineering, and also I would like to share the details of that program. So I'll just click on undergraduate program. So I'll click on this tab, regular program, right? Under this, you will find the different streams which are available with us, and those streams will be helping you out in making your career bright. So according to your area of interest and qualification, you will click on, like for example, if you're interested in engineering, you will click on this, and these are the streams which are available under engineering program. We do have computer science, ECE, robotics, automation, mechanical, mechatronics, IT, and so on. So if I am interested in aerospace, what I'll do is I'll click on this part, and I will come to know that yes, it's a 4 years degree with 8 semesters. And for further details, I'll click on here, and I'll come to know about the eligibility criteria, fee structure, and everything. So if I brief you about the eligibility criteria of this program, it says that you need to have only 60% aggregate marks in 10+2 with physics, mathematics, chemistry, and English as compulsory subjects. Along with that, you will have to qualify our in-house test, which is called LPU NEST. So that means this test is mandatory for you to clear if you are interested to take admission in BTech program. And these are the subjects which you must have studied in your 10+2. So once the eligibility part is clear, you can check out the other details here, the curriculum part, right? Then the fee structure. So if I talk about the curriculum part, we have distributed all the syllabi here, which is year wise as well as term wise. So anybody who wants to know that in first year what all subjects are taught, so you can see the subjects under autumn term as well as spring term. Similarly for second year, third year, fourth year. In one go, you come to know which all syllabus and topics will be covered along with the complete syllabus. Then the electives offered in the curriculum: aircraft maintenance, Six Sigma, space engineering, designing. So these are the elective offered in the curriculum. Similarly, the fee part, if I talk about fee, the fee for this program is 1,20,000 per semester, which is without any scholarship. But we are giving very good scholarships, and those scholarships are divided into 3 different parts. We call them category 3, category 2, category 1. So depending on the category in which the score of the student falls, the particular scholarship will be awarded to the student. For example, if a student appears for LPU NEST test and the score falls in bracket 3 or category 3, he or she will be given 28% scholarship, and the applicable fee will be 86,400 per semester. Similarly, if the score falls in bracket 2 or category 2, student gets 38% scholarship, fee will be 74,400, and in category 1 we are giving 48% scholarship to the students, and the applicable fee will be 62,400 per semester. So that means there are different categories, different ways through which a student can win scholarships. Like you can win on the basis of this LPU NEST test. Of course, we are giving scholarship on the basis of your 12th percentage. Like if the percentage falls between 80 to 89.99, in this case, you will be given 28% scholarship. If the score is between 90 to 94.99, you get 38%, and 95 and above will make you eligible for 48% scholarship. Similarly, there is another category that on the basis of your JEE mains percentile, we are giving you scholarships. So the slab says if the percentile is between 85 to 90, you get 28% scholarship. If the percentile is between 90 to 95, you get 38%. And if the percentile in JEE mains is more than 95, you get 48%. So that means in LPU, there are different categories through which a student can win scholarships. But you need to remember one thing, that even if you are eligible for 3 or 4 different categories of scholarship, but at the time of admission, you will be given only one scholarship, and that too which is highest. For example, if a student is eligible for scholarships in 3 different categories, can be on the basis of 12th percentage also, can be on the basis of LPU nest or JEE mains percentile. So what we do is at the time of admission, we compare all the categories, and in whichever category he or she is getting the best scholarship, the best one will be given to the student. Another good point in LPU is that whatever scholarship you win in your very first semester, that gets carried forward for the complete program. For example, if you are winning 48% scholarship in the very first semester, this 48% benefit will be given to you for all 4 years, all 8 semesters. That is the best thing in LPU. Now coming to the other part also, then the fee details and all, you can just check it out. There are other categories also on the basis of which a student can win scholarships. Then we do make you sure about the details, program outcomes, the salient features. You can go through them in detail from the website, and of course how to apply. You will have to visit our portal, which is called admission.lpu.in. So a student will have to register himself or herself at that admission portal, and once the registration is done, you have to pay the fee for the test, which is 1,000 in case of boys and 500 in case of girls. So accordingly, the slot booking of the exam will be done, and the student will appear for the exam, which is called a remotely proctored test from home. So the last date for this test to apply is 15th of July. That is the last date you need to remember. You need to rush off immediately, because 15th July is the last date to apply for LPU nest. And of course, the last date for the test will be 20th of July. So you need to be very sure that you will be applying for the test latest by 15th, and the exam's last date is 20th of July. So once you appear for the exam, the result will be out. And once the result is out, within 7 days after the declaration of the result, you will be taking the admission, the provisional admission, provided it should not exceed the last admission date, which is 25th of July. So with this, I'm making sure that you are already aware about the process. And last thing what I would like to tell you is, if you want to know the details of the webinars, so there is another tab on the same page on admissions. On the extreme left, you need to go to this LPU's Edu-Fair webinars. So once you click on this, you'll come to know that yes, there are webinars which are the past webinars which have already been done, and the webinars which are upcoming in the coming days. So if you are interested to join any of the webinars, you need to click on this tab and make sure you join the webinars accordingly. And last but not the least, I would like to tell you, and I would suggest you to jot down these details. The website of LPU is lpu.in, and this is the email ID, admissions@lpu.co.in. If you want to drop a mail regarding your program, any inquiry you want to make. And of course, we do have landline numbers available, 01824 517 000, another number 404404. Thank you so much for your patience. Wish you all the best. Have a nice day. Over to you, Ruby ma'am.
Thank you so much, sir, for the detailed information about the admission part. And with this, if I would like to request Dr. Amit to please join us.
Yeah, yeah.
Yes,
Over
sir.
here.
All right.
So if any queries are, yeah, you're audible. Very much.
All right. So can we take a few queries, sir, with your permission?
Please go ahead. Please go ahead.
All right, sir. So there is as you were discussing about all this practical things, so there were a few queries from our attendees regarding that. So there was 2 queries from a same attendee, so I'll accumulate in one. The query is that greater the angle of attack, lesser will be the lift. What is this phenomena? And another query from the same attendee is, so from these engines, we can give a direction to the air pressure consumed by the engines and convert them into thrust. So can you throw some light on this?
The first one, what is being spoken about, the angle of attack. If I'm talking about that angle of attack variation, so once the angle of attack is nominal till 10 degrees or 12 degrees, till that particular time we are getting a lift of 1.2 or 1.1 somewhere. But as the angle of attack starts increasing, uh, the airflow structure over the aerofoil, it tries to deviate, it tries to get separate. So for that particular reason, these wake formation zones are being created, due to which the stalling occurs. So once the stalling occurs, the aircraft won't be getting that short amount of lift. So it was there way back in past, but after that there were certain implementations being done that these airfoils were being attached with flaps and slats, right? So addition of flaps will engage or say increase that surface area of that flow structure, and obviously we will be getting more amount of coefficient of lift. So lift will be increasing further on addition of flaps to it, right? So that is what is the first part of the answer is. And the second, when I'm talking about engines part of it, yes, we can utilize that, but normally reverse thrust, they normally they occur when we talk about in terms of landing part of it. So airflow structure can be utilized, it can be taken back, but it cannot be put it into that reverse way to propel that or say provide kind of thrust to that particular engine. So that cannot be done. Yes.
Thank you so much, sir. And Divyansh Saini, I hope you got the satisfactory answer from our expert. So moving on to the next query. So the next query is from Tenzin, and he wants to know that how an active flow control blowing effects on aerodynamic
Yeah.
coefficients and efficiency.
Good. So active, when active kind of control we are talking about, these active kind of control are something where we are putting blowing air, high energy air, because I told you the flow over aerofoil, it tries to get the tendency of that flow is to get separated, right? So in order to avoid that separation, we either blow in high energy air or we suck in high energy air in order to make that flow streamline. So that is what is called method of blowing and method of suction that is being done in order to avoid that flow separation over the air. So these are the two methods that basically are being utilized to or say provide that there should not be any kind of flow separation, because we want that flow to be flowing smoothly over that aerofoil surface. It should not get separated, because separation will bring the drag.
All right. Thank you so much, sir, for the detailed
Thank you.
information. And so there is another question, and I hope admission nominee, Mr. Neeraj, sir, he'll be better explain this. So, sir, a student, Shashank Bhardwaj, he wants to know about the cutoff of BTech CSE. So, sir, can you please clarify the student about this?
See, basically, as far as the cutoffs are concerned, there is no hard and fast rule that yes, if a student scores this much marks, he or she'll be getting a particular scholarship, right? But there are tentative cutoffs available. So what we can do is, once the student registers, we discuss with them about the last year cutoffs. So depending on the last year cutoff, we tell them that there can be a variation of 10 to 15 marks. So according to that, so the cutoffs, they can just have a vague idea, a rough idea that, okay, if I'll be scoring this much percentage or this much marks, I may be getting a particular slab for the scholarship part, right? So it varies. It starts from 150 to 180 marks, right? So it goes up to 330, 350 also, because the total marks for the this particular entrance is 400 marks. So out of 400, you can say if somebody is planning to get a category 1 scholarship, he or she need to target somewhere around 330, 340, then only the category 1 scholarship will be given. But yes, there can always be a variation between 10 to 15 marks. This number can come down also, and it can go up also, depending that at what point of time you are preparing for the exam.
Thank you so much, sir. So we have another query from an attendee. He has given the LPU Nest exam. So he wants to know that can he reappear for it?
Yes, of course, the LPU Nest exam, what we are doing is we are giving a second chance to the student. Let's say somebody appeared for the exam and due to any XYZ reason, he or she couldn't clear it. Maybe the student missed the exam due to the clash with some other exam, or he was not present on that day. So we are giving a second chance, which is totally free without any charges. So you need to book a slot yourself by consulting your area person, or you can just give us a call on the number. And even the slot option is coming in your dashboard. It will be written second slot option. So once you click it, you need to just tell on which particular date and time you plan to appear, and without any charges you can book your second slot also.
Thank you so much, sir, for this wonderful news for our attendees. This is a summer bonanza attendees that you can, for a price of one, you can reappear twice for this LPU Nest exam and get maximum scholarship. So thank you so much, sir. So Dr. Amit, the attendee wants to know that he wants to join ISRO after the completion of this course. So how LPU will facilitate in this, and how he can be
LPU,
compatible through that?
obviously, when I'm talking about joining ISRO, that is all comes down to 4 years of study. That what we normally do. So LPU will provide the best academics that what is being required to be helping to join ISRO, right? So somewhere down the academics has to be very strong, and you need to be backed down by strong experimental work also. So LPU can just provide you the best of academics and the guidance through which you could be able to through with the ISRO. Right? That is what we can basically provide.
Definitely, definitely. So attendees, LPU faculty or mentorship is here to explore that in-depth talent in you, and they will facilitate and they will assist in you to be the part of such great organizations. So yes, sir. So sir, we'll take up last but not the least question. So a student wants to know that how LPU will help the student to approach the placements, especially in government sectors.
Yes. What I need to tell you that during your third year and once we move down to a specialization part of it, we have divided this into two parts. One is called the government jobs and one is called the higher studies. So when you look for all these gate exams and all, because see for government jobs, everyone nowadays require gate score, right? So with the Department of Aerospace and with the LPU, everywhere we provide this gate preparation basically, which are being embedded in our course also, where you'll be able to get that insight of that gate, and then you'll be able to qualify that up. Once you are qualifying that up through that particular gate score, you can either go for higher studies or either you can go work as a go for a jobs, because every jobs what we're talking about right now, that is being associated with these gate scores. And when we talk about all these government organizations, DRDOs and all, there are certain sets of exams that are being conducted throughout December and all. For that, you need to prepare, and that also will be provided the ample amount of support, the assistance, whatever it is being required, that will be provided by LPU staffs, faculties over here, whether it's a mechanical, whether it's aerospace or any other stream we talk about. So that is how we give out the support to the students.
Thank you so much, sir. So, so there is another query that is popping up again and again, and I would like to take that, sir. So the student wants to know that is there any kind of uniform for BTech? Neeraj, sir, Dr. Amit, if you
No,
want to
no, no, no,
comment on this.
not exactly right.
No,
Not
there is
exactly.
no specific, yes,
No
sir,
specific. Yes, but
specific.
for placement classes and all, like I'll say, when we coming down for interviews and special conduct classes, there we need to be very much specific, because we need to, you're going for a corporate jobs, you need to prepare yourself in that formal attire, right? So we need to have at that particular time. During the placement classes, yes, you will be having, but not during your class times.
Thank you so much, sir. So thank you so much, sir, for resolving, Neeraj sir and Dr. Amit, for resolving all the queries of our attendees. And with this, I would
Most welcome.
suggest our attendees that decisions determine destiny. So decide your own date and take the admissions as soon as possible. So we'll conclude the session with this. And thank you, attendees, for sparing time and participating in today's webinar. And we appreciate you all for being here. And I believe your knowledge has been enriched by this webinar. And also, I would like to express my appreciation to the experts for their valuable contribution to our today's topic. And thank you so much. I'm sure your years of research, your years of experience will definitely assist the audience, help the audience to find the right path. So thank you so much, sir. Thank you. And
Thank you
with
so
Have a
much.
this,
nice day. Thank you.
Until next
Thank
time,
you.
I
Have a
run
nice
sign off session. Thank you, everyone.